Hey guys, welcome back. Today we're going to talk about Unit 11, Day 2, factoring the difference of two squares. So before we get into the actual factoring part, we want to review what a perfect square is. And a perfect square simply comes from making squares. So if you have a square tile 1 by 1, we say 1 squared is equal to 1. Well, the next perfect square would be a square that has sides 2 by 2. So you probably recognize this as 2 squared equals 4. So the next perfect square in the series would be 4. I'll illustrate one more. I think you guys get the hang of it. The next perfect square would be a square that has sides 3 by 3. So we say that 3 squared is equal to 9. So 9 is going to be the next perfect square in the series. Now, we really should know all of our perfect squares up through, I would say, at least 144. That happens to be 12 squared. So numbers that are perfect squares would be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, which is 11 squared, and 144. So beyond that, you really would want to be using a calculator, but up until this point, I would recommend that you know those perfect squares. Okay, so let's talk about how to factor this. This is actually my favorite factoring technique because it's pretty quick and easy. When you see the difference, and that's the key, it's got to be a difference, it has to be subtraction, it doesn't work for addition, of two perfect squares, first thing you want to do is you want to create two sets of parentheses, all right, because you're going to be multiplying two binomials. Now, what goes in the parentheses is pretty easy. We're going to take our first term here, and we're going to take the square root of that and put it in the first position. Now, the signs for the difference of two perfect squares are always different. It doesn't matter what order you put them in, but one's going to be plus, one's going to be minus. And then what we're going to do is we're going to take the square root of that second number, or second term, I should say, it doesn't have to be a number, and we're going to put it here. So the final answer is simply going to be x plus 5 times x minus 5. Okay, and once you kind of get that pattern down, these go very quickly. So let's take a look at the next one. What did we say? Two sets of parentheses. All right, so I'm going to take the square root of the first term, and that's going to go here and here. So that's y and y. One sign's addition, one sign subtraction. Then what I'm going to do is I'm going to take the square root of the second term, and that's going to go here and here. So that's going to be 7 and 7. So our factored answer is going to be y plus 7, y minus 7. And once again, it doesn't matter what order you put the addition or subtraction. The order of the terms is important, but not the order of the signs. The second one kind of illustrates that. So very similar to the last one we did, but notice the difference in order here. The number comes first. So I have to take the square root of 49 first and put 7 at the beginning of each binomial. Again, signs, addition, subtraction doesn't matter. Then I take the square root of the second term, which is y squared. The square root of y squared is just y. So this time the answer is 7 plus y, 7 minus y. Notice how that's different than the previous example. Okay, a couple more here. Again, it's good review of your perfect squares, especially with the numbers. Variables are pretty easy. Square root of x squared is just going to be x and x. I'll just mix it up here. I'll put minus plus just to illustrate it doesn't matter. And then we take the square root of 16. So obviously I think you guys know that's going to be 4 and 4. There are my two factors. Okay, m squared minus 36. Big difference here, really. I just changed the variable. Not a big deal. It's going to be an m and an m instead of an x. Signs alternate, and the square root of 36 is 6. So m plus 6 times n minus 6 is your factored answer. So now the last one we'll kind of practice here. Remember, you're just taking the square root of both. So you can see numbers, or I can just put variables in there. In this case, there are no numbers. It's a squared minus b squared. Well, the process is the same, remember. Take the square root of that first term. Whatever that is goes in the first spot of each binomial. So in this case, there's going to be a and a. One sign's plus, one's minus. Then I take the square root of the second term, and that's going to go in the second position. So that's b and b. So our factored answer is simply a plus b times a minus b. Okay, hope you got it. So now at this point, here's where I'd like you to pause the video, factor this on your own on a scrap sheet of paper, then resume the video and check your answers. All right, so we're gonna do 5 or 6 of these, and then I think we'll be good for this lesson. You can go ahead and do your Delta math assignment in the next day or two. Okay, x squared minus 100, 2 sets of parentheses, square root of x squared is x, 1 signs addition, 1 sign subtraction, square root of 100 is 10. So x plus 10 times x minus 10. And again, the order doesn't matter. So if you had x minus 10 times x plus 10, it's the same answer. X has to be first in each binomial. 10 has to be second, though. That is important. Okay, the next one. Pause this, try it on your own, then resume the video. All right, this one's actually super easy, but it has a tendency to confuse some people. Starts out pretty straightforward, but remember, 1, that's our first perfect square. The square root of 1 is simply 1. So if you see x squared minus 1, it factors to x plus 1 times x minus 1. Okay, before you pause the video, just be careful of the order on this one. All right, so remember, the first term in the expression has to go first in the parentheses. So the square root of 9 is 3. You're going to have to start with a 3. 1 signs plus, 1's minus. Square root of x squared is simply x. So this is 3 plus x, 3 minus x. Ooh, challenging one. All right, try this one. Okay, so again, notice what I like to do first every time. I just put the parentheses down and go through your process. This is a little bit more challenging because we've got a number and a variable in each term. Well, just take the square root of each one. So the square root of 81 is simply 9. So I know I have to have a 9 in each part. And then the square root of m squared is just m. So the square root of 81m squared is just 9m. Signs are different. And I go through the same process here. I'm going to take the square root of the second term. Well, again, I like to do it one at a time. Some of you might be able to do it both at once. But the square root of 100 is 10. And the square root of n squared is n. So that makes the square root of 100n squared 10n. And this would be your final answer right here. 9m plus 10n times 9m minus 10n. And our last one, another challenging one. Pause the video, resume it, see if you've got this one. Okay, there are my parentheses. I'm going to take the square root of this first term. Square root of 25 is 5. Square root of x squared is x. So I have a 5x and a 5x. Signs are different. And the square root of 9y squared, the square root of 9 is 3. Square root of y squared is y. So I get a 3y and a 3y. And there's your final answer. Okay, so that'll be the last one we practice here. I think you guys are set. Please do the corresponding Delta math assignment that goes with this lesson 11.2. And as usual, guys, if you have any questions, please do not hesitate to reach out to me.